Hello everybody, my name is Sergey. This week I want to talk about soldering. I've got a number of things that I need to solder for work. It's not a lot, it's just a couple of, well, three cables. But I thought since I have to do this, why not actually make a video on soldering and how it works? Because when you've got a cable like that, for example, I've seen a lot of people that talk about the like the thick big gauge wires, and that those wires can actually take a lot of heat, which, well, is how it works. We'll get into that in a second. But connections like these, for example, right? if you if you have a look at those pins, they are actually quite small. And you've got plastic. Well, this is not all plastic, but there's some of these connections, I think, actually, that these other ones are plastic. So what you want to do is you don't want to overheat that, because obviously if you overheat it, then it's not gonna be snug. It's not gonna fit in there anymore, which is, you don't want that, obviously. So um yeah, why not just get into it and see what it's all about. What you can see in front of me is a soldering iron. This bit here actually is the iron itself. That is a controller for it. We'll get into that in a second. Usually what you see when you buy these things is just the just that bit, just this bit, and then that plugs straight into your wall socket. This one has temperature control, which is important. We'll get into that. And the other important things are the solder itself, which looks like that. Just it's like a wire, and flux paste. Now, solder is made of it's basically a alloy, and it's made of two metals. You've got tin and you've got lead, and there are different kinds of solder, um, which have different ratios of tin and lead. This one, technically, usually you should see that noted on them. This one is 40% lead and 60% tin, so that's a 60-40 solder. This is what you usually see being used in electronics. There's also the 50-50, um, and there is also the 40. No, the 37 and 63. That one's it's a bit of a special one, and these ratio relate a lot to the melting point of the solder. Usually, what you see with the 50-50, this is 60-40. But with the 50-50, it's got a melting point of around 220, I think, or 215 degrees Celsius. The 60-40 is a bit lower, at 190, if I'm not mistaken. And the 63-37 one is even lower at 183. And the reason why that matters is, first of all, you can, so obviously with the different ratios, you can use less heat, and that means that your electronics are going to be safer anyway, because obviously you're not putting that much heat on them, and you're not going to cause any kind of damage. Or there is also an important bit called the plastic state of the solder. So essentially, you've got the melting point is where it starts to get into the plastic state, and then probably roughly around 20-30 degrees on top of that is where it's actually fully melted. Although the plastic state differs between solders. For example, on the 50-50 is roughly I think it's like 25 degrees, but the 60-41 is lower at like 5 to 7. And then what you've got with the 63-37 one, that's basically got virtually no plastic state. So the moment it hits its melting point, which is pretty low anyway at 183 degrees, it's gonna melt instantly. It's just gonna turn into a liquid. Um, the other important thing to remember about soldering is that what it what soldering actually is, what actually happens between the solder and the copper that you're trying to solder in electronics. Anyway, um, solder has a very important property called wetting. So what happens is that molecules, copper molecules and molten solder molecules are mixing together, forming a new alloy. And for that to happen, which is obviously what you want to happen, and that's one of the nice things about solder, because that kind of thing happens at a pretty low melt point at 100 and around roughly 200 degrees. And for that to happen, you need a clean surface, clean wire, and obviously you don't want any oxides or anything like that. And that's where flux paste comes into play. Um, Now, flux paste, what this does is that it facilitates that. So it cleans in its it's basically just like solder. It melts. It's got very low melting point. Once you put it on a wire or a surface or whatever, when it's just a solid like this, it will not do much. But once it's hot, it's just about active enough to clean off all the oxides and all the impurities and whatever you've got on the surface you're trying to solder. And that is why you use those two together all the time. So you want some of that paste. Well, first of all, you want to clean your surface, and then you want to put some of that paste on it just to make sure that it's really clean. And that will then facilitate the soldering, the wetting process, which is basically what we call soldering anyway. And so I was just gonna do that, and I was just gonna solder a couple of these wires, because I need to do this for work basically. Because what I've got is I'm just gonna use this to send MIDI data down this cable and to a um, out to a surface basically. So this is a surface mount plug. So that's what you want to do. You just want to mount that on a surface anyway. So I was just gonna check these wires and just make sure that they plug in at the right spot. Right, see if that's right. Okay, so that's the middle one. So what we're gonna do is we're gonna solder that onto the middle one, the middle pin. So since this cable is since this bit of the wire is actually exposed, I was gonna talk about actually making the the solder joint happen, and how to do that properly, because obviously you want the solder to stick onto the joint and to actually hold it there. Because, for example, with the solder, that the solders, like for example the 50/50 one that has like a longer plastic, I think it's got like a 25 degrees worth of range when it comes to its plastic state. Then what you want to do is, while it cools, you want to hold it in place, because if it's half molten, then it might move, and it might create a bad connection. Um, but obviously, one of the reasons why you use the 60/40 one is because it's got a just about right plastic. So what I was gonna do is I was gonna put this on, and what I normally do, I've got it set to. I mean, you should be able to see. I've got it set to 230 degrees, and what's happening now essentially is that it's heating up the tip, so the actual iron bit itself. And on the screen, we should see roughly 230 degrees. Oh, that's kind of spot on actually. And what we want to do is you want to try and see how this thing melts, because what you're looking at specifically is you want to be able to make the soldering happen in roughly 2 seconds. Because if you've got more than 2 seconds, even if the temperature is low, if you're holding that pin on to the tip onto the whatever joint you're trying to solder, trying to make, for example, this pin here, it will transfer a lot of heat into that, and it might damage it. Obviously, again, you don't want to put a lot of pressure onto it, because that will damage it even more. So you want to make the soldering happen in roughly 2 seconds. So anyway, in theory, that's what we're going to try and achieve. So what I want to do is make sure that that happens. Now this is 60/40 solder here, and what we're going to try and do is we're going to see if it melts, right? But before we do that, we've got to look at this tip here. This is a very pointy tip, and pointy tips, what's important, I'm hoping that this temperature is just about enough for this. With the pointy tips, right at the very top of it, right there, you're not gonna have basically the heat transfer is not gonna be quite as effective as it is up here, for example, because you've got less surface. So you've got to think about which part of the tip you're gonna be working with, and if this kind of tip is actually the right one, because with many of these stations, you can have different kinds of tips, and you obviously want to change them and use the right ones. Or some people have more than one soldering iron, and so what you're gonna try and do is see if you can cause some melting to happen in roughly 2 seconds with this area, because that's what I'm gonna be using. So let's see if that happens. Not quite. Well, it melts, but it's not really fast enough. So that's why we want to pump up crank up the temperature. And let's try 290 degrees. Let's see if that does anything. We're just gonna give it a second to reach that. And let's see how it melts now. Yeah, there we go. That was nearly instant. I would say that's a bit too much, because it was that fast. So we're gonna turn it down now. Let's try roughly 270. I don't do this process every time, obviously. I'm usually around 260, 270, depends on what I'm working on. Because obviously you want temperatures to be a bit higher if the surface you're working on is larger, but this is not. So right, so we'll try 270, see how that does. Yep, that is pretty good. And then we're gonna want to clean the top, the soldering iron tip, just like that. Most of these soldering stations come with a sponge like that, where you can actually clean the tip. And then we want to put, obviously, we want to try and clean as much as well. You shouldn't really be doing this with the fingers. It's rubbing alcohol will do a better job, but I don't have any on my in reach at the moment, so I'm just gonna do this. So basically what we're trying to do is we're trying to see exactly how long that wire is gonna be. I would say that's roughly about enough. And then you want to cut it. I've got scissors here. You want to cut it at the length that you want it to be at, just like that. And then you want to put it through the paste. Because what you want to do before you solder, you want to apply solder on both the wire and the surface. Unless you're working on a PCB where you've already got the surface is, small and clean enough, and the whole thing will just work. Paste melts easier than the solder, so you can get that on quite easily like that. And then you want to get some solder, and try and get that onto the wire. Now, what you could do is you could just keep hold the solder up here and just kind of drip it on to the wire, but that's actually wrong because you're applying too much heat on the wire, and not, just you have to be careful with a cable like this where the wires are not quite that big. And this is the bit that I was trying to find because on YouTube, because a lot of people are using these really huge large gauge wires which can take a lot of heat, but these are not. So if you put too much of that 270 degrees onto the wire, it will melt. It could melt the entire thing and cause a short, and we don't want that. So I'm trying to do this so you can see. So what you want to do, try and get closer to the camera. So you want to get some of that solder onto the wire, and this is a very awkward position to work in, but well, I'm trying my best. Anyway, so here we are, trying to get that solder onto the wire. So if we warm the wire up just enough for it to take that solder on, that should be roughly enough. Right, there we are. So what you're seeing there is just gonna clean that tip. That's how it should look like. So now we've got the solder onto the wire, and that is the bit that will then solder on to your pin or whatever joint you're trying to make. The process for that is just the same. Usually you can just get some of that paste on there, although that's a little bit more difficult. So I'm just gonna use this solder bit to get some of that paste out of there and onto the pin, just like that. And then same idea. You just wanna try and get that solder onto the pin, but obviously these pins have a hole in them, so you don't want to block the hole. You just want to get a tiny bit of that solder onto there, just like that. Right, and now if we grab the wire and we put that through, roughly that should be good. Now you can see that the solder is already kind of holding the wire in place. Now this is the 2-second part. Well, the other ones were as well, but obviously not quite as critical as this, because now if you put too much heat on there or pressure, now it can damage things. So we're just gonna put some of that solder on there. We've already got the paste and the flux paste, and just a bit of heat should hopefully do the job. Yeah, so what you're looking at is that's a pretty solid connection right there. And what we're gonna do now is we're just gonna repeat the process. Right, cool. Now that should technically be this cable. Solder onto all the 5 terminals. Now let's check continuity and see what's what. So it should be roughly the same as, well, it should be exactly the same as these as the plug. So I'm just gonna check that. I really need a better DMM. I'm gonna get one day. But you know how it is. If you can get it to work, I'd rather not spend the money. So, yep, that is good. That's the right one. Yep, that's good. Yep, that's good. And we've got 2 more. Yep, that's the right one. And the last one. Yep, that's good. Alright, so that should be all done. I obviously, as long as far as sealing goes, you can use a number of materials. I was just gonna use plastic welding, which is not necessarily part of this video, but anyway, that's how this kind of thing is done. So yeah, so right, I'm just gonna switch cameras again. Right, so roughly the idea is that you've got 3 things involved here. You've got the solder itself, you've got the flux paste, and the soldering iron, or the soldering station, just like this one, in case you've got a temperature controller on it. Electronics, temperatures wise, again, like if you can get your soldering skills in check and you can do a soldering joint in like 2 to let's say 5 seconds at max. Although if you're working on an IC or something like that, then that can be a pretty bad idea. That's one of the reasons why people use IC sockets. Yeah, and you're just gonna wanna try and do that basically. Practice helps in this kind of thing. Obviously, I've been doing this for a while, so it's not, for me it works. But if you're just starting out, then I think you should practice before you actually work on a PCB or something like this. Right. Anyways, thanks for watching. I think that's it for today. And I'll try and upload again next week. Hopefully, I'll make it. I've got some work to do during the weekend. I was trying to upload videos during the weekend, but if I've got work, then I don't know if I can do that. Although if I can shoot the video during the week, then uploading shouldn't be much of an issue, I hope. Yeah. Right. Thanks for watching, and yeah, I'll see you next time. Cheers.